Hi friends, today I am giving a lecture on how to solve third order linear homogeneous recurrence relation. In the previous video, we are already solved one example problem. So now in this video, we have to solve another example problem. Okay. Now we go for our given problem. Solve the following recurrence relation. 2 into a suffix n plus 3 is equal to a suffix n plus 2 plus 2 into a suffix n plus 1 minus a suffix n for n greater than or equal to 0 with the initial condition a0 is equal to 0, a1 is equal to 1 and a2 is equal to 2. Okay. So before going to solve the given problem, we all already know that the general form of the third order linear homogeneous recurrence relation. So this is the general form of the third order linear homogeneous recurrence relation. C suffix n into a suffix n plus c power n minus 1 into a suffix n minus 1 plus c power n minus 2 into a suffix n minus 2 plus c power n minus 3 into a suffix n minus 3 is equal to 0 for n greater than or equal to 3. So this is the general form of the third order linear homogeneous recurrence relation. Here nth term can be defined in terms of its immediate previous three terms that are n minus 1, n minus 2 and n minus 3. Okay. Now the right hand side part of the given recurrence relation is equal to 0. Hence we can say that it is a homogeneous recurrence relation and the order of the given recurrence relation is 3. Hence we can say that third order linear homogeneous recurrence relation. Okay. Now what is the characteristic equation of the given general form of the recurrence relation 1? And this is the characteristic equation of the general form of the given recurrence relation, that is c power n into k cube plus c power n minus 1 into k square and c power n minus 2 into k plus c power n minus 3 is equal to 0. So this is the characteristic equation of the general form of the third order linear homogeneous recurrence relation, where c power n and c power n minus 1, c power n minus 2 and c power n minus 3 are called the constant coefficients. Okay. So before we are solving the given problem, I am already told that this is the general form of the third order linear homogeneous recurrence relation and its characteristic equation. So once we are defining the general form and the characteristic equation, now it is very easy to explain the given problem. So because of that reason, first I am writing the general form of the third order linear homogeneous recurrence relation and its characteristic equation. Now we can go for the given problem. Given recurrence relation is this one. Okay. Now according to the general form, so the right hand side part of the recurrence relation can be sent to the LHS side. So the right hand side is completely 0. So and here n plus 3 term, n plus 2 term, n plus 1 term and n term is there. So that it is a homogeneous recurrence relation with degree 3. But it is not in general form of the given recurrence relation. So to convert this given recurrence relation into general form of the third order linear homogeneous recurrence relation, first we have to substitute. So n is equal to n minus 3. Okay. after substituting n is equal to n minus 3 in this equation, so then we are getting the general form of the third order linear homogeneous recurrence relation. Okay, now given recurrence relation is not in the form of general form, that is equation 1. Okay, so hence substitute n is equal to n minus 3. Substitute n is equal to n minus 3. This is the equation 3. In equation 3, n is equal to n minus 3 is substituted in equation 3. Now 2 into a suffix n plus 3, in the place of n we are substituting n minus 3 plus 3 minus a into n minus 3 plus 2, minus 2 into a suffix n minus 3 plus 1, plus a suffix n minus 3 is equal to 0. Okay, here n greater than or equal to 0, that means in the place of n we are substituting n minus 3 greater than or equal to 0. Okay, so here minus 3 plus 3 cancel, so then we are getting 2 into a suffix n minus a into a suffix minus 3 plus 2, that is minus 1, a suffix n minus 1, next minus 2 into a suffix minus 3 plus 1, that is n minus 2, plus a suffix n minus 3 is equal to 0. So here n minus 3 greater than or equal to 0, that means minus 3 can be sent to the right hand side. So then we are getting n greater than or equal to 3, and this is equation 4. Okay, now observe the equation 4. This is in the general form of homogeneous linear recurrence relation. Okay, so now compare equation 1 and equation 4 for getting c power n, c power n minus 1, c power n minus 2 and c power n minus 3 constant coefficients. So now compare 1 and 4 equations. Compare 1 and 4 equations. After comparing equation 1 and 4, so what is the c power n value? C power n is nothing but coefficient of a suffix n. Here a suffix n coefficient is 2. Hence we can say that c power n is equal to 2. Okay. Next one. Here a suffix n minus 1 coefficient is c power n minus 1. Here a suffix n minus 1 coefficient is c power n minus 1 is equal to minus 1. Here signs are also important when we are comparing equation 1 and 4. Next one. Here a suffix n minus 2 coefficient is c power n minus 2. Here a suffix n minus 2 coefficient is minus 2. Therefore c power n minus 2 is equal to minus 2. Next one. So a suffix n minus 3 coefficient is c power n minus 3. So here a suffix n minus 3 coefficient is a 1. So c power n minus 3 coefficient is 1. Okay. So these values can be obtained by comparing the given recurrence relation after converting into general form. So this recurrence relation is compared with the general form of the third order linear homogeneous recurrence relation. Then we are getting these constant coefficient values. Now these constant coefficient values are substituted in equation 2 for getting the characteristic equation of the given recurrence relation. So now substitute the above values in equation 2. Substitute the above values in equation 2. So after substituting the values in equation 2, so first c power n value is how much? That is 2. So therefore 2 into k cube. Next one, c power n minus 1 value is minus 1. So therefore minus k square. Next, c power n minus 2 value is minus 2. So then minus 2 is substituted in this equation. Then we are getting minus 2k. Next one, c power n minus 3 value is 1. It is substituted, plus 1 is equal to 0. Okay. So now this is equation 5. Okay. Now therefore equation 5 is called the characteristic equation of given recurrence relation. Okay. So once we are getting the characteristic equation, then we have to find out the roots of the characteristic equation. Okay. Now we have to find out the roots of the characteristic equation 5. For that one, we have to use short division method. In that one, we have to write the coefficient. K cube coefficient is 2, k square coefficient is minus 1, k coefficient is minus 2, and 1 coefficient is also 1. Okay. First put 0 here. Next one, at this position, last we have to get 0 value. Okay. So to get the value 0 in this position, what value we have to write? So for example, so k is equal to 1. Okay. So 2 plus 0, that is nothing but 2. 2 is multiplied with 1, that is 2. 2 minus 1, that is nothing but 1. 1 is multiplied with 1, that is 1. Next one, minus 2 plus 1, that is nothing but minus 1. Minus 1 is multiplied with 1, so that is a minus 1. 1 minus 1, that is equal to 0. Okay. So here in this position, we are getting the value 0. Okay. For that one, what value we have to write? We have to use the trial and error method. Okay. Next one. In the same way, second one also in the same way, same procedure. Here we are getting the value 0. For that one, what value we have to substitute? For example, I am taking minus 1. First here we have to put the value 0. 2 plus 0, that is nothing but 2. 2 is multiplied with the minus 1, that is minus 2. Minus 2 plus 1, that is nothing but minus 1. Minus 1 into minus 1, that is a plus 1. 1 plus 1 minus 1 value is a 0. Okay. So now here in this place also, here we are getting the value 0. Okay. put the value 0. So now here k is equal to, for example, half. I am taking half. Okay. So 2 into 0. 2 plus 0, that is 2. 2 into half, that is plus 1. Minus 1 plus 1, that is a 0. Okay. So this is the constant. We have to leave that constant. There is no problem at all. Okay. So now what values we are getting? K is equal to 1, k is equal to minus 1, and k is equal to half. Okay. So therefore the three roots of the given characteristic equation are, so k is equal to 1 comma minus 1 comma half. Okay. So therefore k1 is equal to 1, k2 is equal to minus 1, and k3 is equal to half. k3 is equal to half. Okay. Now observing these three root values, okay, the three roots of the characteristic equation are real. Three roots are real and distinct. So hence we can go for which case? We can go for case 1. Okay, case 1. We are already know that case 1 is nothing but the three roots of the given characteristic equation are real and distinct. Then we can go for case 1. Here the three roots are real and distinct. Hence we can say that we can go for case 1. In case 1, what is the general solution of the given characteristic equation? The three roots of the given characteristic equation are real and distinct. Then the general solution can be represented by a suffix n is equal to a into k1 power n plus b into k2 power n plus c into k3 power n. Okay, so this is the general solution of the given characteristic equation where a, b, c are the constants. Okay, now substitute k1, k2, k3 values in this equation. So substitute k1, k2 and k3 values in the above equation. So therefore a suffix n is equal to a into, what is k1 value? That is 1. So 1 power n. Next plus b into, what is k2 value? K2 value is minus 1. So minus 1 whole power n plus c into, what is k3 value? So that is half. So half power n. So this is equation 6. Okay. So a, b, c are the real constants. Okay. So now this is the solution of the given recurrence relation. Okay. Now we have to find out the a, b, c values. Okay. For that one we have to use the initial conditions. What are the initial conditions? So the initial conditions given in the problem are, so A0 is equal to 0, A1 is equal to 1 and A2 is equal to 2. So 0, 1, 2. So take A0 is equal to 0. Take A0 is equal to 0. So that means N is equal to 0. So now put N is equal to 0 in equation 6. Okay. Take A0 is equal to 0. That means N value is equal to 0. Put N value is equal to 0 in equation 6. So therefore A0, A suffix N means A0 is equal to A into, so 1 power N, that is 1 power 0 plus B into minus 1 power 0 plus C into half power 0. Okay, so A0 value is 0, that is equal to 1 power 0 is nothing but 1, that is 1 into A, that is A. So minus 1 power 0, that is 1, 1 into B is B, plus half power 0, that is 1, 1 into C, that is C. So therefore A plus B plus C is equal to 0. So that is equation 7. Okay, next one. So take next initial condition, A1 is equal to 1. So that is N is equal to 1. So put N is equal to 1 in equation 6. Okay. So A suffix N means A1. A1 is equal to A into 1 power 1 plus B into minus 1 power 1 plus C into half power 1. Okay. So what is A1 value? A1 value is equal to 1. So 1 is equal to A 1 power 1 is nothing but 1. 1 into A is nothing but A. Minus 1 power 1 is minus 1. Minus 1 into B is minus B. Next one, half power 1 is nothing but half. Half into C is nothing but plus C by 2. So this is equation 8. So A minus B plus C by 2 is equal to 1. That is equation 8. The third initial condition, so take A2 is equal to 2. That means N is equal to 2. That is, put N is equal to 2 in equation 6. In equation 6. Okay. So A suffix N means A2. A2 is equal to A into 1 power 2 plus B into minus 1 power 2 plus C into half power 2. Okay. Next, what is A2 value? A2 value is 2. So 2 is equal to 1 square into A, that is 1 into A, that is A, minus 1 whole square is nothing but 1, 1 into B is nothing but B, plus half square is nothing but 1 by 4, 1 by 4 into C is nothing but C by 4. So that is equation 9. Okay, so now we are solving 7 and 8 and 9 equations. So first we are solving 7 and 8. So solve 7 and 8 equations. Solve 7 and 8 equations. Okay. So here first one, 7th equation is A plus B plus C is equal to 0. Next one, 8th equation. So here I am taking 2 is LCM. So that is 2 into A, 2A minus 2 into B, that is minus 2B plus C. Okay. So is equal to 1. So therefore 2A minus 2B plus C is equal to 2. So this is also equation 8. Okay. We are taking the LCM. In the same way, this equation becomes 2 is equal to, so 4 is LCM, that is 4A plus 4B plus C. So therefore 4A plus 4B plus C is equal to 8. So this is equation 9. Okay. We are modifying equation 8 and we are also modifying equation 9. Okay. Next, take equation 8. So that is 2A minus 2B plus C is equal to 2. Okay. Now, first equation 7 can be multiplied. Sorry, no problem at all. Okay. Now, minus, plus, minus. Okay. Now, here plus C, minus C. Both are cancelled. Plus C, minus C, both are cancelled. So, next one. Minus 2A plus A. So, that is nothing but minus A. Plus 2B plus B. That is plus 3B is equal to only minus 2. Okay. Minus A plus 3B is equal to minus 2. So, this is equation 10. Okay. Next. 8th and 9th equations we have to solve. Okay. So, solve 8 and 9 equations. Solve 8 and 9 equations. So, 8th equation is 2A minus 2B plus C is equal to 2. Okay. 9th equation 4A plus 4B plus C is equal to 8. Okay. Minus, here minus, here minus. Okay. So here plus C minus C both are cancelled. So now minus 4A plus 2A, that is minus 2A. Okay. Minus 2B minus 4B, that is minus 6B is equal to minus 8 plus 2, that is minus 6. Okay. Now this is equation 11. That is equation 11. Okay. Now solve 10 and 11 equations. Solve 10 and 11 equations. So that is minus A plus 3B is equal to minus 2. Next one, minus 2A minus 6B is equal to minus 6. Okay. Now this equation is multiplied with 2. This equation is multiplied with 2. So then we are getting minus 2A plus 6B is equal to minus 4. Okay. Now, so this is equation is same, minus 2A minus 6B minus 6. Okay. So now here plus, here plus, here plus. Okay. Minus 2A plus 2A cancel. So 6B, that is 12B is equal to plus 6 minus 4, that is plus 2. Okay. So B is equal to 2 by 12, that is equal to 1 by 6. Okay. Now B value is substituted in equation 10. Okay. So B value substituted in equation 10. Okay. So minus A plus 3 into B value is 1 by 6 is equal to minus 2. Next, minus A plus 3 by 6, that is a 1 by 2 is equal to minus 2. So here minus A is equal to minus 2 minus 1 by 2. So that is equal to 2 LCM minus 4 minus 1. So that is minus 5 by 2. Minus minus cancel. So therefore A is equal to 5 by 2. Okay. So once we are getting A value 5 by 2 and B value 1 by 6. Okay. Substitute A and B values in equation 7. Okay. Next one. Substitute A and B values in equation 7. Substitute A and B values in equation 7. Okay. So what is equation 7? A plus B plus C is equal to 0. A plus B plus C is equal to 0. What is A value? A value is 5 by 2. B value is 1 by 6 plus C is equal to 0. Next, 5 by 2 plus 1 by 6, this one. 5 by 2 plus 1 by 6 plus C is equal to 0. Okay. So now we are taking LCM 2, 6. LCM is 6. So 2 into 3. So that is 15 plus 1 plus 6C is equal to 0. Okay. So now 15 plus 1. So that is 16 plus 6C is equal to 0. So now 6C is equal to minus 16 and C is equal to minus 16 by 6, that is minus 8 by 3. Okay. So now A value is 5 by 2, B value is 1 by 6 and C value is minus 8 by 3. So therefore A, B and C values substituted in equation 6. Substituted in equation 6. Therefore A suffix n is equal to, what is A value? 5 by 2. So 5 by 2 into 1 power n. Next, what is B value? B value is 1 by 6 plus 1 by 6 into minus 1 power n. Next one, what is C value? Minus 8 by 3. So minus 8 by 3 into half power n. Half power n. So this is the final solution of the given recurrence relation. So it is very important while solving these equations. Okay, if any mistake, small mistake can be done, total problem is wrong. Okay, so this is the final solution of the given recurrence relation. Okay, so thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasarao. Okay. Next, our answer is correct or not. We have to do verification. So here initial conditions are A0 is equal to 0, A1 is equal to 1, A2 is equal to 2. Okay, so A0 is equal to 1 means put n is equal to 0 in this equation, then we are getting the value 0. Okay, A1 is equal to 1, put n is equal to 1, so we are getting the result as 1. A2 is equal to 2, put n is equal to 2, then the answer we are getting as 2. So the 3 conditions are satisfied, then we can say that our answer is correct. Now we have to verify, so our answer is always correct. Okay, so thank you. In the next video, we are solving another example problem. Okay, in the previous video, we are already solving one example problem. So, based on case 2. Okay, now this problem based on case 1. Okay, next problem in the next video we are doing is based on case 3. So, because of that reason, we have to remember these 3 cases. So, each and every case contains one example problem.